Hello, all of you. Back again with Chapter 8 Motion, Class Ninth, presented by E-Physics class, myself, Dipali from Fatima Convent High School. Let us move further to the next part of the chapter. Now we studied what is speed, an average speed, uniform speed, non-uniform speed. Now what if this speed is given direction? So the topic for this session is speed with direction. What does this mean? Now we know that whenever we are moving or changing position in particular amount of time, but if there is no direction, we call it as speed. But if you are moving or changing your position in particular amount of time in particular direction, then what is that quantity called? That quantity is named as velocity. The rate of motion of an object can be more comprehensive if we specify its direction of motion along with its speed. So the quantity that specifies both these aspects is called velocity. Velocity is the speed of an object moving in definite direction. The velocity of an object can be uniform or variable. It can be changed by changing the body object speed, direction of motion, or both. When an object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity. It is calculated in the same way as we calculate average speed. In case the velocity of the object is changing at a uniform rate, then average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity divided by 2. Mathematically, VAV is equal to U plus V upon 2, where VAV is the average velocity, U is the initial velocity, and V is the final velocity of the object. Speed and velocity have the same unit, that is meter per second. Measure the time it takes you to walk from your house to your bus stop or the school. If you consider that your average walking speed is 40 kilometers per hour, estimate the distance of bus stop or school from your house. At a time when it is cloudy, there may be frequent thunders and lightning. The sound of thunder takes some time to reach you after you see the lightning. Can you answer why this happens? Measure this time interval using a digital wristwatch or a stopwatch. Calculate the distance of nearest point of lightning. Speed of sound in air is 346 meter per second. So, did you understand what does the velocity mean? Like speed, velocity is another quantity, say velocity is defined as change in speed in particular direction upon time. Or simply you can say velocity is equal to speed plus direction upon time. The symbol of velocity is same as speed v. Here speed plus direction, that is distance plus direction, upon time is also termed as displacement, as we know that displacement is distance plus direction upon time, which is represented by v is equal to s upon t, and the unit is meter per second or meter s raised to minus 1. Like uniform speed and uniform motion, we can talk about uniform and non-uniform velocity as well. And non-uniform velocity. Now, how shall we compare this? We have time, distance, and direction here, as we are talking about speed with time. Now, here there are three possibilities. Time is equal, distance is equal, and direction also is equal. But non-uniform velocity has a little bit special case. Time is always equal. The direction time is always equal. Here distance can be unequal and direction can be equal. Distance can be equal, but direction can be unequal, or both are unequal. This is what is non-uniform velocity. Now, whenever we have non-uniform velocity, we need to have in practical life average velocity, like average speed. What is this average velocity? Then average velocity is initial velocity plus final velocity by 2, which is represented as VAV is equal to U plus V upon 2. Now, what is initial velocity and what is final velocity? Now, let us understand this with the following diagram. Take an example. There are 4 points A, B, C, and D. An object is moving from point A to point B and the distance is 10 meters. From point B to C, 10 meters, and from point C to D, 10 meters. In a particular direction, say from south to north. So, this is uniform velocity, and the velocity or the speed with which it started at point A is called as initial velocity, and the point where it came at rest or still moves further, but point D for us here will be the final velocity. Generally, when an object is stationary or at rest, its initial velocity is always 0 and final velocity is x. But if the object is already moving and it comes at rest, then final velocity is 0 and initial velocity is x. This you will understand better in the next part of the chapter. Now let us talk about non-uniform velocity. Again we take point A, point B, point C and point D. Now the distance between the point is 10, 5, 8 centimeter or meters. Now the object is moving from A to B, B to C and C to D in the direction south to north. Here the direction of the object didn't change, but the distance is changing. In the particular interval of time, time remains constant. Then this is non-uniform velocity. The second case is from A to B to C to D. Ten meters, 10 meters, 10 meters is the distance. And south, north. Now the object is moving from A to B, B to C, but here the direction changed. Time and distance are constant. And then again C to D, the direction changed. So this is again non-uniform velocity. Case 3, again the object is moving from A to B to C to D. This is 10 meters, 5 meters, 8 meters. Then object is moving from A to B, B to C, the direction and the distance both are changing. And from C to D, again the direction is changing. So we can say that this is non-uniform motion. The average velocity is the initial plus final divided by 2 because we are talking about 2 points, the final position, and the initial position. Origin is the initial position and where it stops is the final position. So we can say that at point A, that is your initial velocity, and at point D is the final velocity. And the average of these 2 points is v plus u divided by 2. So whatever is the velocity of the object at point u plus the velocity of the object at point v divided by 2 is called as the average velocity. There are the cases, as I told you, when the object is at rest or stationary. The initial velocity is always 0 and final velocity is always x. Now, when the object is already in motion, and comes to rest, at that moment u is x because it is already in motion, means it will have some speed or velocity when it is already in motion, and its final velocity because it comes to rest will always be 0. This concept is very important for the numericals. Is this clear to you? Okay. So we shall sum up here for this part of the chapter. Thank you.